Ladies and gentlemen, welcome to the channel of Beyond Consultancy, where we discuss all things operations excellence. My name is Herman Lemmens. In this keynote, we will explain the Fishbone Diagram. This keynote is the first of a series. In a second keynote, we will present a case study. The Fishbone Diagram visualizes the possible causes of an effect. It was created by Kaoru Ishikawa during the 1960s in Japan. It originated from quality defects prevention programs in the manufacturing. Let's first take a look at an example. This is a rather witty example. The effect is bad coffee. There are many causes leading to bad coffee. For instance, using too much water leads to bad coffee. Another one is that being rude to the people who make the coffee leads to bad coffee. But okay, I think you get the idea. The fishbone diagram has the characteristic fishbone shape. It is structured around the so-called 5M and E clusters of possible causes. This acronym stands for machine, man, method, materials, measurement, and environment. Let's investigate this in some more detail. The first cluster of possible causes is called machine. It relates to the equipment and the tooling involved in the effect. It investigates the processing variability in terms of accuracy and precision, the status of the maintenance, and the technological capabilities. The second cluster is called man. It relates to people, more specifically to the way people handle the products and operate the equipment. It relates to the difference in ways of working between the shifts, to the people's level of training and their skills, and lastly, their level of knowledge. The third cluster is called method. It connects the clusters man and machine. It covers the clarity and the completeness of the work instructions, also known as the standard operating procedures. It covers the technical correctness of the process description, the organizational effectiveness of the procedures, and lastly, the quality control process itself. The next cluster is about the materials. It checks the possible variations with the raw materials, the parts, and the indirect materials. It also checks for possible operational variations at the supplier sites. And lastly, it reminds us to check for information provided by the suppliers themselves. The cluster measurement includes the work done by the inspectors and the quality of the calibration of the machines, the tooling, and in particular, the test equipment. This cluster also includes managerial influences. The last cluster relates to environmental causes with elements like temperature, humidity, and acts of nature. Let us now proceed to demonstrate one thing and another. We will investigate the causes which led to a sudden and unexpected machine stop. It happened during one of the weekend shifts. They couldn't get the machine running again. The people tell us that they did not do anything out of the normal. They applied the usual lubricant, but sometime later the machine came to a sudden halt. Upon investigation, it turns out that the equipment supplier had issued a new lubricant with different working characteristics. He had timely issued a change request, the quality department had approved and had updated the process description, and had given a verbal heads up to the people. Except the changes had not reached the weekend shift. They didn't know about it and based their actions regarding the application of the lubricant on an outdated maintenance operating procedure. The question now becomes, how come the procedure wasn't updated? Well, it turns out that the related documentation department had a serious backlog and a much needed position was still vacant. Now, we could go on with the question as to why the position was vacant and so on and so forth, but I think you get the general idea of how the fishbone diagram works. The process of questioning is also known as the 5 whys. The idea is not to stop at the first answer, but to continue asking questions, peeling the proverbial onion layer by layer. This brings us to another question of where to start with corrective actions. In other words, how to prioritize the changes. Lean offers us an approach. For every cause which we would like to address, we need to ask 2 questions. The first question is about the likeliness that the cause is a major one. Is it very likely, somewhat likely, or unlikely? The second question is about the ease of solving a cause. Will it be very easy, somewhat easy, or will it be difficult? The answers need to be seen in combination with each other. The advice is to start the improvement actions from the green combinations. Evidently, the red combinations are not viable at this point. And with this, we have come to the close of this keynote. Thank you for being here. I hope you found it interesting. Please leave your views in the comment section below, and I hope to see you again.